Let's try to put some sense to when climate change began. So we are saying many things, right? In the previous chapter I said climate has changed throughout the Earth's history and it always changes and has changed in the past because of changes in the orbit and the amount of energy received from the sun or the way the energy is distributed, even though the energy may be the same because of changes in the ellipticity of the orbit, the tilt of the Earth's axis to the orbital plane, and the precession and so on. So in general, when we say climate change, we mean the current climate change, because now this is what we are mostly talking about. But when we talk about this, we have to answer the question about, has it changed in the past? And we said yes, it has changed a lot of times. Will it change in the future? We will look at that a little bit later on. So now you can ask, when did the current climate change begin? So the title of this podcast is Ajja. When did climate change begin? So Ajja is a word in my language which is called Kannada, which is Kannada, Kannada, which is from the language of Karnataka in southwest India, where we speak this language. So Ajja is grandfather in that language. So let's read chapter 4 about the change beginning. Nearly all 97% of climate scientists agree humans and their impact on Earth are making the difference. It's clear that we are burning fossil fuels and we are increasing carbon dioxide. Just like we used some isotope of oxygen to look at change in temperatures in the past, we can use some isotopes of carbon to see where that carbon came from, and we can show that the increasing carbon in the atmosphere is coming from burning fossil fuels. And who is burning fossil fuels? We are. So that's very easy to do. Okay, so there is science behind it. We're not just making some blind claim and so on, as you may hear somewhere, because we'll talk about climate politics soon. Okay, if you're older, you can follow up on my podcasts on carbon isotopes, oxygen isotopes, and how we use them to determine these things about past temperatures or current CO2 changes. The principal geologist at the British Geological Survey, remember we just looked at some figures from the British Geological Survey about past climate changes. He said, we had an incredible impact on the environment of the planet, of our planet. Another geology professor later added, we are just realizing the scale and the permanence of the change. What is the permanence of the change? If you are saying increasing greenhouse gases like CO2 warms the planet, then the question is, how long will the warming continue? Well, that depends on how long the CO2 that you put into the atmosphere will stay in the atmosphere. That's called the residence time. Remember, before we talked about the storage and the flow, and the atmosphere is a storage of carbon dioxide, and we said it started at 280 parts per million by volume before the Industrial Revolution around the 1700s, and now it is at 420 some parts per million by volume, because as I'm recording it may be 424, but by the time you're listening to this it would have gone up. Okay, so that's what we are talking about. And once you put it in the atmosphere, it stays there for 100 years, 200 years, and 300 years, depending on how and where it is circulating. Some of it may go into the plants, into the ocean, into the soil, but on average it stays there for many centuries. So that's the permanence of the change. And there is another kind of permanence. If you're melting glaciers, remember it takes 100,000 years to build glaciers, but we can melt it in a decade or two. That's a permanent change, because even if we stopped global warming, it will be a long time before the glacier builds back up. So recent human activity is the reason why Earth is warming, and also why it's happening at such a rapid rate. We already looked at past climate changes, and we know how it has warmed and cooled in the past because of natural processes like radiation from the earth, from the sun changing. Some feel we should even mark this as a new era, much like the age of the dinosaurs, and call it the age of the humans. And I mentioned this before, there was some attempt to call it the Anthropocene, and Anthropocene means the age of humans, but as we said, the expert committee of the geologists said that is still not time, because the change we have made is still not big enough or permanent enough to make it a new geological period. Okay, recent human activity refers to the past 200 to 250 years, when technology began changing the way we people live in a very massive way. It hugely changed the way people live, the way we live, the way you are living. You are very young, you don't even know what things were like in my own lifetime. When I grew up, there was no telephone in the house because we were poor. There were landlines everywhere. Now you have mobile telephones. There were no mobile telephones. There wasn't a TV in the house I grew up because we were poor, and there were TVs in India, but they were not colored, and so on and so forth. Okay, all these things change rapidly. It all began with a revolution, although one that wasn't a war. The Industrial Revolution, which you may have heard of, was a time of new ideas and new inventions, and it's a great thing. So many things were invented, and slowly machines, cars, airplanes, trains, everything came, and we began to fly around and move around. In the United States, it started in the late 1700s with one cotton mill in Rhode Island, which is the northeastern state of the United States of America on the Atlantic coast. More factories followed soon. Earlier, mostly everything had been made or built in homes or in small workshops, like a blacksmith sitting in his little shop and making things like axes and hammers and nails. People spun their own thread, sewed their own clothes, and made their own candles even. They made little chocolates as well. So you can see here how people were going around in horse buggies and sitting here. But buildings were there, bricks were there, and you can see some manufacturing happening in the back here. But Henry Ford had not invented the first car yet. With new machinery, production, which means making things, shifted to large shared spaces called factories. These factories were powered by coal. They produced large amounts of goods, and very fast as well. It became easier to buy factory-made items like clothes, for instance, than to sew them by hand. It was easier and cheaper, and many styles were available as factories kept producing clothes fast in large numbers, and new designs were coming up, and the poor lady here got a rest from making things by hand under candlelight, because electricity came along, and so did light bulbs and light and so on. Soon factory-made gas lamps replaced homemade candles. Then electricity replaced gas lamps. In time, whole cities needed electricity. Power plants were built to supply electricity to great numbers of people. These stations converted energy sources like coal and oil to electric power. We were just churning out electric power and firing up gas lamps and machines and making things. Everything looked fantastic, and then we realized, oh my God, all that coal and oil we are burning is producing CO2, which is being released into the atmosphere. We'll see some timelines at the end of this chapter where early on, even in the 1800s, there were scientists who realized that what we were doing was going to have a consequence. and a bad consequence at that. Okay, so in homes, fireplaces were no longer needed to provide heat. You are not burning little pieces of wood and so on. Burners and furnaces were developed to keep houses warm. They used oil and gas. Coal, oil, gas, all are called fossil fuels. They are natural resources that come from long buried plants and animals from the past, as we saw before. Silurian, Devonian, and Ordovician and so on produced plants, and the material got buried and became coal and oil and gas and so on. Okay, so long buried plants, animals, and ancient life forms that held carbon gave us coal, oil, and gas. When they are burned to generate power, they release the carbon as CO2 because they are full of carbon, because they are photosynthesized materials. Remember, if you're old enough, you've probably seen the equation. 6CO2 plus 6H2O gives you C6H12O6 plus 6O2. If you don't understand the equation, don't worry about it. But here is a nice big building. Either it's a factory billowing smoke because it's producing something very rapidly, like the needs that we talked about when we talked about the Lorax. Remember? You can go back and listen to the Lorax if you don't know what I'm saying. By the early 1900s, horses were traded in for cars. For long distance travel, people took trains, and by the 1930s, people flew around in airplanes. First mail, postal packages and mail and letters were carried by planes, and then people started flying around in planes. These forms of transportation burned coal or oil or ran on electricity from power plants, but all needed fossil fuels and all emitted CO2. Life obviously became more and more expansive, with people going from country to country, town to town, across big countries, seeing things, making cultural exchanges, visiting other cultures, and also colonizing other countries. As you know, some European countries colonized many countries across the world, like the British came to India, Portuguese came to India, and Dutch went to Indonesia, and the French and everybody else was in Africa, and so on and so forth. Okay, it's those CO2 emissions from factories and power plants and cars and trains and airplanes that send extra greenhouse gases into the atmosphere. Using fossil fuels creates dirty energy, polluting the air with climate changing gases we called greenhouse gases. Clean energy, on the other hand, causes little emission pollution, and renewable energy has practically zero emissions. What does it mean? Energy is coming from the sun, which is actually being used by the plants to produce food, which is what gave us coal, gas, and oil. But these leaves and the algae that are photosynthesizing, they are solar cells. They're capturing sunlight. They're using CO2 to produce carbohydrates and sugar, which is energy for us and energy for other animals, right? So can we also build solar cells to capture the solar energy to drive our factories, our cars, our trains and planes and automobiles? Wind energy is being used now as well. Wind is always pushing water around and producing waves. You can put a little turbine in the water and churn the turbine and produce energy, just like a hydroelectric power plant produces energy by storing water and releasing it in heavy quantities into a turbine and rotating the turbine. If you don't understand, don't worry about it, but there is dirty energy which is coming by directly burning fossil fuels, and there's clean energy coming from sun and wind and hydroelectric and nuclear. So we'll talk about these things when we come back. Okay, so the change began in a large way with industrial revolution, which started in the 1700s, and when we say climate change, we're talking about this change that started recently since the industrial revolution. We'll come back and continue. Okay, see you.